Okay. What's missing? Addition and subtraction. Okay, so there's some things we can do here. Any ideas where we want to start first? Kind of goes back to order of operations. Parentheses, but parentheses, and people still have trouble with this. When they say parentheses, they mean, is there any work to do inside? So there's no work to do here, inside the parentheses. There's no work to do inside the parentheses. What do these parentheses, what are these parentheses representing? Why are they there? They're there to show what operation? Multiplication, yeah. They're there to show multiplication, so that's lower on the totem pole. Kids just see parentheses and they're like, oh, I'm supposed to do parentheses first. No. What's inside? If there's nothing to do inside, then the parentheses are actually multiplication and you gotta hold on, okay? So parentheses then comes exponents, okay? So what are we gonna do with this exponent? Is it okay to bring it in?
Yeah.
Yes, because there's no addition or subtraction. No addition or subtraction. Number one mistake here. Why do I bring it in here? Why do I not bring it in here? No addition. Okay. Number one mistake. Or confusion, I should say. All right, so 5x to the fourth, y to the fourth. So what's this going to be? This is going to be, would we be okay to write 9 right away? 3 squared. If you want it, we can write out 3 squared, x squared, and then y to the third squared. If you can go right to this next line, that's okay. X to the fourth, y to the fourth. So this would be 9, x squared, and then this would be y to the 6th. Those parentheses mean multiplication. But there's multiplication all in here, there's multiplication all in here. So it's just one big multiplication problem. We don't really even need those parentheses anymore. We're just going to multiply what we can. Okay? So they're kind of redundant right now because this is all multiplication here, this is all multiplication here, and then this is just saying multiply everything together. So we multiply the numbers, 5 times 9, 45. How do we multiply the x's? Add those exponents. 6. And then y to the 10th. Add those exponents. I was trying to think, like, I just wanted to make sure that you guys understand, like, if there was a z here, because this probably isn't the best problem. If there's a z here, can I still multiply those together? I can. Yeah, they don't have to be like terms. When do I have to have everything exactly the same? When we are adding and subtracting. But for multiplication, it's a free-for-all, all right? So even if that z was there, I could still multiply my x's, I could still multiply my y's, and then this z would just tag along. Does that make sense? How come, if that z wasn't there, okay, let's do this. Let's just take it, we'll take it from right here. So 5x, and you can just watch if you want y to the fourth. Let's change it to a plus. How come I can't add them either? I have an x, I have a y, but you have to have the same amount. So if this is an x to the fourth, this has to be an x to the fourth. Right? If this is a y to the fourth, then this would have to be a y to the fourth to add them. Let's do that. Let's do just different problem. 5, let's do x to the fourth, y to the fourth, plus 9. Let's say it ends up being x to the fourth, or it is what? Now we have two terms. Terms are separated by plus and minus signs. How do I add them? They have to have the exact same variable with the same exponent, and then all you do is add the numerator, or the coefficients. All you do is add those numbers in front. Those are called the coefficients. 14, and then this just stays. X to the 4th, y to the 4th. So there's a lot of rules, okay? It's like your mother. You got to follow these rules, right? That's all that math is. Follow all these rules. Keep them organized. Memorize them, and you'll be fine, right? But there's just all these rules. You really have to. It has to be kind of almost a visual thing. You have to kind of see that. Okay, there's a plus sign, and then your brain has to go into that path. And keep in mind, we're doing a whole bunch at once, but the more you can retain, the easier it's going to be, because this is going to be stuff like in the middle of a problem. Okay, how are we doing? We've got a few more. What do we do? Let's do this one. X plus 3 cubed. This comes up a little bit at the beginning. We're doing pretty good. We've got just a few more. All right, so this was just annoying. There's a pattern if you can remember it, but we only do it a few times. So I think it's better just to go at it. Can we bring that exponent in? No, because we got that addition. So it is a matter of, we're just going to have to write it out 3 times and enjoy a few moments of foiling. I always do the first 2, but sometimes it's better to have the smaller one. So I'm going to actually try to bring this one down and then foil these 2. It doesn't really matter. It's just, you can always switch it to. All right, so first gives us x squared. Outer gives us 3x. If you're pretty good at foiling, you could try to do outer and inner together and then add those, but don't feel you have to. So outer would be 3x, inner is 3x, and last then is plus. If you can do outer and inner together and go right to, that would then be 6x. You can maybe try it on your homework if you get it wrong and just be like, you know what, I'm just going to take the time to write it out. All right, so now FOIL on steroids, right? You just got to get it kind of organized a little bit better. This x has to go to all 3, and then this 3 has to go to each term, all 3 terms. Okay, so how do I multiply x times x squared? What do I do with those exponents? Add them, yes. Who was the first person on Earth? Adam, yes, you add them. Like my one joke, guys, you better laugh. All right, so x times x squared, add those exponents. 3. X times 6x. You're still adding the exponents. You got an exponent of 1 and an exponent of 1, so that takes you to 2. So plus 6x squared. And then, where am I at? And then the end, x times 9 gives us 9x. Now, when I first did it, then I would just keep going on here, which is fine. But I kind of like to do this. 3 times x squared gives me 3x squared, and so I'm going to line it up with the other x squared. And then 3 times 6x takes me to 18x. So I'll just line that up there. And then 3 times 9 takes me to 27. And then add them together. Whether this was over here to the side, we would just add them. Otherwise, this is x to the 3rd. Oh, maybe I should slow down. 9x squared, are we okay? We add the coefficients, and the x squared just stays. This gives us what? 27x, and then 27. Okay, so we did that. We should be good there. Let's just So we got like 4 more problems. 4 more years, right? Okay. Let's start over. We just need like a humongous wall of whiteboard. Wouldn't that be? That's like a math person's dream. Okay. Too small. When we get into calculus, not always, but some long problems. Oh, so fun. Okay, here we go. 5 times x minus 3 minus 2 times 5x plus 6. So just be careful here. Oh, yeah, minus that. Okay, we should be good. Okay. All right, what do we want to do? What do we do first here? Do we know how to do this? Yes, the one where we haven't really talked. Well, we kind of talked about distributing an exponent, but this is official distribute. Yeah, and that's fun. I mean, that's a piece of cake, right? This is kind of FOIL off of steroids, right? It's not even a full FOIL. So this is nice. So we just distribute the 5, multiplying is nice because it goes to anything. So 5 times x is 5x. 5 times negative 3, negative 50. The only thing, what do we have to be careful on this next one? I don't distribute a 2. You must take the sign with. Take the sign with. Do not forget about that negative. And Tom, the teacher, he always would say, respect the negative, respect the negative. Okay, so don't forget about that little negative. So this is going to be negative 10x, but the number one mistake is it's not 12, it is negative 12 or minus 12. Okay, and then we collect like terms. So 5x minus 10x, negative 5x, and then negative 15 and then negative 12, negative 27. Okay, that's all right. Perfect. We always started late. All right. Oops, sorry. Okay, let's take a look at. Do we know how to do this? The square root of 12 plus the square root of 75. In order to add, again, it's that addition that's causing trouble. In order to add, you have to have the same number under the radical. So these can simplify. 12 is 6 times 2, but what's a better choice? 4 times 3 or 3 times 4. Why is 4 times 3 or 3 times 4? Why is that a better choice? Because 4 is a perfect square. So the square root of 4 goes to 2, and the square root of 3 stays underneath. 25, it might be the obvious one, which is good. What do we want to use there? 25 times 3. 25 times 3, because the square root of 25 is 5, and then you still have the square root of 3. Now when we add, we only add the numbers in front. It's just like 2x and 5x. So I can add the numbers in front, the 7 and the square root of 3 stays. How do we multiply? Let's just do an easy one. Let's do the square root of 3 times the square root of 7. How do we multiply those? Do they have to be the same? No, for multiplication, you just multiply the numbers underneath. So this would be the square root of 21. What happens if it was the square root of 3 plus the square root of 7? So I'm adding, there's nothing I can do with the square root of 3, nothing I can do with the square root of 7, so that is done, right? It's kind of like having x plus y. At some point, you just got to leave it. All right, so are we okay with that? That's kind of like 3 problems, but just different things to cover. Okay, let's do this and then one more. Let's do the square root of x minus the square root of y times the square root of x plus the square root of y. Two underneath equals 1 outside. The reason the square root of 25 is 5 is because the square root of 25, I really have two 5s. 2 underneath equals 1 outside. So we're going to do a FOIL. What's the square root of x times the square root of x? I have 2 underneath. This is the square root of x times x. 2 underneath equals 1 outside. There's a lot of ways to look at this. We could also think of this, x times x gives me x squared. But this, how can I write this? Exponent on top, radical on the bottom. What's 2 over 2? Takes you to 1. So there's a whole bunch of different ways to look at it, but I kind of just like 2 underneath equals 1 outside. 2 underneath, 1 outside. It's kind of the definition of a radical in very general terms. Okay, so now how are we going to do this one? Square root of x times square root of y. I'm supposed to multiply what's underneath, so this is just going to give me the square root of x times y. Kind of like here, took me to 21. Okay, here I'm doing x times y. I can't really multiply those together, so I'm just going to have x, y. All right, what about this one? Don't forget about this negative. So I've got negative, and then square root of y times square root of x is yx. Same thing for last. Negative sign. What's the square root of y times the square root of y? Y. 2 underneath, 1 outside. But don't lose those negative signs. This is actually fairly important, but we're going to end on this. Now, are these two the same? Yx and xy? Yes, those are the same. This is a positive, technically like a 1 outside here. But then this is minus. So those two are gone. And so my answer is x minus 1. Does anyone know what it is when you have the same thing, square root of x in front, square root of y at the bottom, and the signs are opposite? Remember that word? It's not like you have to, but that comes up a lot. Or not a lot, but a little bit, especially in chapter 1. Conjugate. Conjugate, have we heard that maybe? Conjugate is when you change that middle sign. Okay, so let's stop there, that's plenty. Okay, so you will want to work on that worksheet the best you can, and then we'll see where we're at tomorrow, okay? On the back, it's just moving negative exponents and positive exponents and up and down. There are a few that you cannot do, okay? So there are a few that is not possible, okay? So we can talk about those tomorrow, but just if you really get stuck, be like, oh, that's probably the one that I can't do. There's a few boxes, I think there's 2 that you can't fill in. All right. Give it a try.